All right, we are live. This is the start of our Unit 3 Quadratics Google Hangout study session. It is 5 o'clock right now, so hopefully people will be joining us soon since that's when I said it started. But it seems like everybody likes to get to these a little bit late. So since we're at 0 viewers, I'm just going to start by going through that first page, and hopefully by the time I finish that first page, somebody will jump in and start asking questions about specific problems. But the first page is all about number types, so we just need some good definitions here. Counting numbers, we're going to call those our positive numbers with no decimal. And we don't include 0. So these are numbers like 1, 2, 3, going on forever. The next layer up is whole numbers. That's where we take our counting numbers and we add in 0. All right, this once we get to the whole numbers, we can use this symbol n with a double stroke. And so now this is like 0, 1, 2, ... All right, integers is positive and negative whole numbers. So we need integers to be able to talk about negative numbers, to be able to talk about a number line that goes on in either direction. So they're like this, going all the way to negative infinity and positive infinity. Rational numbers, those are any number that can be expressed as the ratio or quotient of two integers. So any number that can be expressed as a fraction of two integers. So this includes things like 1/3 and 24 over 17, and on and on and on. And they used to believe that every single number, if you just thought hard enough, you could find a fraction that would represent that number, until they came up with irrational numbers. These are numbers that have a decimal expansion that goes on forever. And never becomes a pattern, we'll say. Because technically 1/3 has the decimal expansion that goes on forever, but it's just the pattern, 0.33333. But something like pi, its decimals go on forever and they never become a pattern. They just kind of stay somewhat random. Euler's number is another example. When we put together the rational and the irrationals, we get the real numbers. So for real numbers, we'll say all numbers rational or irrational. every number on the number line is another way to say this. It gets the symbol double stroke R. An imaginary number, all right, is a number off of the number line. So it's a number off of the number line. It is, we really only use the one imaginary number I. Curved that the wrong way, so I is equal to the square root of -1. This is not possible. Therefore, I is imaginary. But just because I is imaginary doesn't mean it's not useful. We can still do a lot of things with I. And the fact that it's off the number line helps us out and helps us have two-dimensional numbers. Now, a complex number is any number with a real and an imaginary part. So we could have a number like 5 plus 3i. This has the real part 5 and the imaginary part 3i. And all numbers can be thought of as complex numbers because you could just have 0i added on to the end and it would still be of this form, a plus bi. All right, let's see if anyone's joined us. Still at 0. That's fine. Hopefully someone will join us soon to ask some questions. In the meantime, I'm going to graph 9 and 10 in 1 minute. All right, so number 9. This one's in vertex form, makes it pretty easy to graph. I've just got to write down what my A, H, and K values are. A is 2, H is -4, K is -2. Go to -4, -2, put a point. And then to figure out what to increment by, I start with the pattern. 1 goes to 1, 2 goes to 4, 3 goes to 9. I'm just squaring my numbers. 4 goes to 16. And I multiply all of these by my A value of 2. So 1 now becomes a 2, this becomes an 8, this becomes an 18, and so on. So that was all times 2. And now, if I go 1 unit out from the vertex, I should go 2 up. So 1 out, 2 up. If I go 2 units out from the vertex, I should go 8 out, 8 up. So 2 units out, 8 units up. At this point, I'm going off the graph, so I'm just going to connect these up with a solid line. Do my best to make it look like a parabola. All right, so that would be number 9. Does anybody want to see a specific problem? Let's see, Aubin, do you want to see a specific problem since you're the only person here?
I don't know if you can hear me, but I think I'm good. I just wanted to pop by.
Okay, well, why don't you pick
I was
one?
having trouble with like the systems of equations one. Yeah,
Okay.
that one.
Like
Like
the last
22.
one? Okay. So, 22. we'll do 22. This is a quadratic linear system. What I'm going to do with this one, I'm going to solve the linear equation for a single variable so that I'll have something I can substitute into the other one. To do that, I'm going to add 3y and subtract 1 from both sides. Is this how you started this problem?
Yes.
Okay. Good. Once we've got it like this, I'm going to take that 3y minus 1 and plug it in both of the places I see in x. So right there and right there. Okay, no, we got to write this down. It's going to be pretty long, but we'll simplify it pretty quickly. Negative 6 times 3y minus 1 squared plus 3y squared minus 4 times the quantity 3y minus 1 plus 78y plus 2 equals 0. All right, a lot of steps to simplifying this. One step is I'm going to need to distribute that negative 4, and I want to expand this here. So I'm going to do both of those in the next step, giving me a negative 6, 3y minus 1 times 3y minus 1. That's what squared means. It means take whatever the argument is and multiply it by itself. Plus 3y squared minus 12y plus 4 plus 78y plus 2 equals 0. And now to continue to solve, I need to FOIL these two binomial terms here. So I think a lot of people like distribute that 6 first or something. You actually have to do 2 other steps before you can distribute that negative 6. You got to expand, and you have to FOIL. And now I'm going to have negative 6. I multiply my first terms, I get 9y squared. 3y times 3y is 9y squared. Are you good with that?
Yes.
Okay, good. Minus 3y plus 1. I do my first outside, inside, and last terms. Plus 3y squared minus 12y plus 4 plus 78y plus 2 equals 0. Now I can distribute that negative 6 in to all 4 of these terms. And this is going to be the biggest this equation is going to get. Negative 54y squared plus 18y plus 18y minus 6 plus 3y squared. I copied down the rest of this. All right, so now we got everything expanded out, everything distributed. Now I'm going to start combining like terms. And as I combine like terms, I'm just going to cross them out so I make sure I get all of them. Let's see, I'll do all my y squared terms. I've got a negative 54, a positive 3. I combine those and I get a negative 51y squared. All right, now I'll do my y terms. I've got an 18 plus an 18. I'm plugging them into my calculator as I cross them out. Minus 12 plus 78. And I get 102y. And then I've got a negative 6, a positive 4, and a positive 2. Those all cancel out to be 0. Kind of nice. That equals 0. All right, now without a C term, this becomes a lot easier to factor. Do you see what the greatest common factor is?
51.
We can pull out a 51. How about a negative 51? And what do they both have? This has 2 y's, this has 1 y, so they both have a 1 y. So what does that leave behind?
Y and 51. No, Y and 2.
Y minus 2. So I factored out. Just make a note that was just factored out. Now I can use the zero product property to set each of these equal to 0. So negative 51y equals 0. And y minus 2 equals 0. In this one, I'll divide both sides by negative 51. It's not going to, I think you can see what it equals. The only number times 51 that equals 0 is 0. But for posterity's sake, we'll write it out. Y equals 0. And add 2, y equals 2. We're not done. What do we still have to do?
Find the X.
Find the X for both of them. So I'm going to use this equation here, X equals 3y minus 1, to find both of these. Let me extend this down. Okay, so y equals 3x minus 1, y equals 3x minus 1. Did I copy that down right? No, x equals 3y minus 1. I swapped x and y. X equals 3y minus 1, x equals 3y minus 1. Plug in these values for y. X equals 3 times 0 minus 1. X equals 3 times 2 minus 1. X equals negative 1. And in this one, x equals 6 minus 1, x equals 5. And then I like to put them back together into the ordered pair that represents the place in the coordinate plane where these intersected. So we've got negative 1 comma 0. And we've got 5 comma 2. Let's see if that's right. The fact that they're integers is promising. Negative 1 comma 0, 5 comma 2. Okay.
All right,
Let's
cool.
see.
Thank you.
Okay. There's somebody else here if they want to ask a question.
Yeah, it's me, Sasha.
Okay, awesome.
Oh.
Third specific one you want to see?
I know how to put it in the matrix, like writing it down on question 12, but I don't know how to put it in my calculator.
Okay. So question 12, you want to do this one with matrices?
Yeah.
Okay, we'll do question 12 with matrices, and then we'll do regression for 13. How does that sound?
Yeah, that's good.
Okay, so each of these is an X and a Y. So I'm going to tell you a little bit about what you've already done, hopefully. And then I'll show you how to put it in your calculator. But we got to go through the whole problem. And so I said we could rearrange our standard form in a special way that kind of helps us get this right into a matrix. And that was to go x squared a plus xb plus c equals y. And so when we plug those values in, I'm going to call this x1, y1, x2, y2, x3, y3. I'm going to plug it in for x1, y1 first, then x2, y2, then x3, y3. This is going to be my A, B, C, and Y column. All right, so this becomes negative 6 squared is 36. Then it's just a negative 6. The coefficient for C is just 1. And my Y value is 140. The next one goes 1, negative 1, 1, 15. And the last column goes 1, 1, 1, 21. Do we have matching matrices?
I don't know.
Okay. We want to do reduced row echelon form on this now, and that's going to give us something that looks like this. And it's going to give us what the values are for A, B, and C. Just write down. It's going to be A, it's going to be B, it's going to be C. All right, so I open up my calculator. What type calculator are you using?
The TI 84 CE, I think.
Okay, let's switch it over. So yours probably looks a little bit more like this. You ever
Yes.
Okay. All right, let's start with a blank screen. First thing I'm going to do, I'm going to hit second matrix. Then I'm going to go scroll 2 to the right to edit. Hit enter. And now this matrix is 3 rows by 4 columns. Are you with me?
Yeah, I got it.
Okay. Now let's enter it exactly as I've written it here. And there is a pattern to it. That third column is always just a column of ones. This is always your x value squared, followed by your x value. And then that last column is always your y value. So you don't have to always write out the rearranged standard form. But I think it can be helpful to get your head around it. All right. So now that I've got the matrix in the calculator, still with me?
Yeah.
Okay, I got to get out of the editing spot, so I do second quit. But then right back into matrices with second matrix. Over to math. And now we need to, I always scroll up. I think it's a little faster. I want to get to this B here, which says reduced row echelon form, RREF. Do you see that one?
Yeah.
Okay, press enter. That brings it to our main screen. Now we need to plug into it which matrix we want to do this to. So we hit second matrix and we select matrix A. That's the matrix we just edited. So it's pulling in the one we just edited. It's going to do the reduced row echelon form on it. And there we have our values, 4, 3, and 14.
Okay.
All right, and so now we want to write the equation of a line that goes through those 3 points. Here's how we're going to write that equation. We're going to say y equals 4x squared plus 3x plus 14. And we're done. All right, do we want to see how to do this next one with regression? It's a little
Yeah,
fast.
sure.
What we're going to do for number 13, we'll start in a very different spot. We're going to start by pressing stat.
Just second stat.
Just stat.
Okay.
No second needed. All right, then we're going to hit enter. Right here, we're editing our stat list. You can see I've got some old data in here. I go up to the top, hit clear to get rid of that data. And all of my lists are cleared.
And then, don't I just put the numbers in?
Yep. So X data goes into L1, Y data goes into L2. All right, do you have an idea what we're going to do next?
Second something. Stat.
Press that again. Now what?
Is it calc?
Yeah.
And then it's 4.
Not number 4. That was linear regression. We want a quadratic equation that's going to hit these 3 points. We press number 5 for quadratic regression.
Wait, and how did we just click stat?
Yeah. Yeah, here I can get rid of that. Stat, over to calc,
Okay.
number 5.
Okay.
Now, I'm just going to go down to calculate. I don't need to store it. I just want to get the values. So I press enter. And look at these values that it gives us. It writes out the equation in standard form and then tells you the A, B, and C values. So -1, 8, and 23. And so regression is normally used when you've got a scatter plot with lots of data. But if you use it with only 3 points, then it perfectly hits the data. It can hit all 3 points, given that no 2 points are share an X value. But if that happens, I think it just gives you an error message, and you would know that you'd have no solution.
Okay, and then I don't have my bullseye at home, and that has the definitions. So.
Okay, fair enough. So which one are you confused about?
Well, I guess I haven't remembered them, so I'll just screenshot.
All right, I'll post this too.
Okay. And then on the test, is it gonna say which is which?
I've got a lot of different ways I can ask these questions. Like asking, would pi be considered a rational number? You'd have to say no. Or maybe something like, are the rationals contained within the reals? And you'd have to say yes.
Uh-huh.
Is -5 considered an integer? Yes. What is the symbol for real numbers? And you'd have to write that fancy looking R right there.
Uh-huh. You just kind of memorize all of it?
You can bring a note card. So
Oh, yeah.
whatever you memorize onto the note card. Hopefully like integers, rational numbers, whole numbers, that's all review. You know, irrational makes sense because the decimal never ends and it never repeats. Yeah.
Okay.
Yeah, I'll post this. Do we have one where we want to see the math worked out?
You do math with the definition?
Can we do math with the definition? I don't know. That's a good question. I was thinking like further questions in the review.
Yeah, we can do one of the 17 or 18, and then 19 or 20, because we just learned 19 and 20.
Yeah. All right, quadratic formula and completing the square. Okay. Yep. Very common question type. I can ask it in a lot of different ways because it's the exact same steps for changing an equation into vertex form. So when I want to convert a problem like number 17 into this completing the square form, the first thing I'm going to start with is getting it into standard form. So I'll add 9 to both sides. It's actually not super necessary that we do this, but it's good to always start in the same spot, so we don't have to adapt too much. All right, now that it is in the standard form, I create this structure here. All right, so what do you notice about that structure?
You just take half of the middle one.
Okay, so that's how we complete it.
Yeah.
But just to set this up, we always write it, the parentheses, x, big blank, parentheses squared, and we always keep the c value. All right, so you're telling me this value here is half my b value, good. And what else do I have to do?
You have to subtract the 100.
Yep. So x plus 10 squared.
If I had a negative 20, would it be negative 10? Or would it just be 10?
That's totally fine. If it's a negative 20, that's a negative 10. And it doesn't throw the problem too much. All right, let's add that 169 to both sides so that we can get this squared term all by itself. And after I do that, select a marker. It's not liking me. Listen. There we go. I get x plus 10 squared equals 169. The beauty of completing the square is now taking the square root, we'll just completely cancel out that squared, leaving behind x plus 10 equals the square root of 169. 13, pretty sure? Yep, 13. But wait, it's not 13. What is it actually?
Do you have to subtract 10 first or after?
After. Do you see what I've written?
Oh, yeah.
Yeah, it's a positive and a negative 13. Every time we take a square root, we have to do that. So now I've got x equals negative 10 plus or minus 13, which means that x equals, let's see, 10 minus 13 would be negative 23. And negative 10 plus 13 would be a positive 3. So both of these answers solve that equation. Questions?
No, that's good.
Yeah. Let's just, if we tried to take a square root at the very beginning and then say that like this cancels out, it doesn't work that way. We can't distribute square roots when we have things being added. Plus, even if we could, we would have a square root over both of these terms. And now we've got a square root over an x. We haven't like made our lives any easier. But by completing the square root and that squared cancel each other out, leaving behind nothing but this nice linear equation. All right, 19, 20, do you have a preference on which one we do?
No.
All right, I'll do
20.
20, okay. Subtract 11 from both sides. I know that this is not the fastest way to do this. Quadratic formula would not be the go-to method, but let's prove that it works. Let's prove that quadratic formula will work for something like this. So I get it into standard form. I consider this to be standard form because I've got a 0 on one side and there's no b value, but it still goes in order from the variable term to our constant term.
Wait, isn't this the one with the b plus or minus the square root of b squared?
Yeah.
Okay, that's what I thought.
Strongly recommend memorizing that, but also probably put it on your note card. So let's find our values for a, b, and c. What is the value for a?
9.
Just a 9. B?
0.
C?
A negative 11.
Okay. So now the quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2a. Let's plug in what we have. So -0. I'm just going to erase that because that doesn't change the equation at all. Plus or minus the square root, 0 squared is 0, minus 4 times 9 times -11, all over 2 times 9. This becomes plus or minus the square root. I'll do that in my calculator real quick. 396 divided by 18, which is going to go to...
You do the square root first or divide it?
We do the square root first, but this square root is not rational, so I'm actually going to stop here. I'm just going to call this my answer.
Okay.
Okay, so I'll say this is fine. There's 396 probably has square factors that we could pull out, but we do a whole unit on that in our unit on radicals, so I'm not asking you guys to learn how to do that yet.
Okay.
So like this. This is fine. Let's see, like, yeah, if we go to the answers page here for, was that 20?
Yeah.
So that simplifies down to the square root of 11 over 3. I'll take what I've got in my calculator and divide it by 18. And then I'm going to do square root of 11 over 3, and I do get the same number. So it does simplify to this, but I'm not worrying about how that simplification's done.
And
All
then
right.
I am going to get on my phone because I have to leave soon.
Okay.
But can we do 11 because I don't remember it?
Okay, so I'll start 11, and if you stop answering my questions, I'll know where you went. Okay, what is the equation of a parabola in standard form? Let me just copy down standard form right there. That has a vertex of 6, 13 and a y-intercept of 85. So that vertex gives us an h and a k value. It actually gives us an x and a y value. If the y-intercept is 85, then it must include the point 0, 85, because when you're sitting on the y-intercept, your x value is 0. So that gives us an x and a y. So we've got an h, a k, an x, and a y. Let's plug all of that into vertex form. So I get 85 equals a times 0 minus 6 squared plus 13. Now let's solve for a. 85 equals a times 36 plus 13. Just solving this linear equation. Then we get an a value of 2 when we're done. So this is good. We can plug this back into vertex form right here.
Okay.
And then once we plug it into vertex form, we got to convert vertex form to standard form. So we get y equals 2 times x minus 6 squared plus 13. Keep the same h and k values, but get rid of the x and y. We were just borrowing them. And now to convert this to standard form, you've got to expand. You have to FOIL. There was a question on the quiz about the correct order to do all of these. You have to distribute. That's a plus 72, plus 13, if you can't read it. And then we got to combine our like terms. Y equals 2x squared minus 24x plus 85. Final answer.
Okay, I'm just copying it down right now.
Okay.
Is that a 40 or 4 after the third y equals 2x squared minus 6x minus 6s plus?
That's a 36 that came from the last terms being multiplied.
Okay. Okay, well, I think I am good.
All right. Well, best
Thank
of luck
you.
to you on the test day.
Thanks.
All right, looks like we're back to 0 viewers. Well, let's see, how much of this do we have done? Still got to do that one there. That page is done. Ooh, some factoring. I think that last one's factoring by grouping, another quadratic formula. Couple there. I'll just keep going through this until somebody else shows up and asks some questions. I think we can probably finish it. To graph this one, I'm going to convert it to vertex form. This is number 10. I set up this structure here, keep that 13. This is always half of that value. Then I subtract away that value squared. All right, now I can go straight to my vertex, -4 comma -3. And from there, if I go over 1, I should go up 1. If I go over 2, I should go up 4 because 2 squared is 4. And if I go over 3, I should go up 9, but then I'd be going off the graph. Connect these up. Put little arrows at the end. That finishes up that page. Factor these. This first one isn't too bad. I add 35 to both sides. P squared plus 12p plus 35 equals 0. Factor this. Create this structure now. And I'm looking for two numbers that multiply to be 35 and add to be 12. Those numbers are 7 and 5. And now I can set those linear factors equal to 0 and solve from there. And I get that p equals -7 and p equals -5. Those are two values that will both make this true. We can double check by plugging them back in. This one here, I'll subtract 12r, subtract 12r. R squared minus 12r plus 32 equals 0, another simple factoring. So we'll create this structure here. Then I need to fill in these with values that multiply to be 32, but add to be -12. I know it's going to be a positive and a negative. Or, my bad, I know it's going to be a negative and a negative. That's the only way I can multiply to be a positive, but still add to be a negative. Let's see, factors of 32. I'm thinking 8 and 4. Those work. Set those individual factors equal to 0. That's our zero product property. Get r equals 8 and r equals 4. Both of those are answers. All right, number 16. I'm sure there's people excited to see number 16 because this is our factoring by grouping example. First thing I'm going to do is get it into that standard form that we've been using. By subtracting 3 to both sides, I get 7x squared minus 41x minus 6 equals 0. Now I want to split that 41. Well, first thing is I recognize that these three numbers do not have any common factors. Now I want to split that 41 into two values. I'll call them D and E. You can call them whatever you want. I know that those two numbers still have to add up to be negative 41. But now when I multiply them, they're going to equal negative 42. Right? Because that's negative 6 times 7 to get that negative 42. All right, that's kind of the whole trick to factoring by grouping, is that what we're splitting that middle term into is your A times your C value. Let's see, factors of 42, negative 42 that add up to 41. I'm thinking negative 42 and positive 1. So let me write that as 7x squared. Let me make sure I do this right. Minus 42x plus 1x minus 6. Let me just make that clear that the factors I'm using of negative 42 are negative 42 and positive 1. All right, greatest common factor in this front group here is 7x. So I pull out a 7x, leave behind an x minus 6. Then the greatest common factor of this second group is actually just a 1, but I'm still going to write it as 1 times x minus 6. Now this goes to this here, still equals 0. The factors we pulled out make their own linear factor, 7x plus 1, and the factor that was left behind stays as a factor. Now we can use those zero product properties, set each of these individually equal to 0 and solve. X equals 6 is one of our answers. X equals negative 1/7 is our other answer. All right, let's see if we've picked up any more viewers. No. All right. 18, solve by completing the square. 18. There's a space over here for it. First thing I'm going to do is add 9, both sides. Get x squared plus 14x plus 86 equals 0. And then create the structure here. X plus something squared, keep the 86. That's going to be a 7, and then I got to subtract away 49. Now I've got x plus 7 squared. 86 minus 49 is 37. All right, it's a plus 37. I subtract the 37 from both sides. We're going to run a little low on room here. I get x plus 7 squared equals negative 37. Take the square root, and we've got I'll write it real small over here. X plus 7 equals square root negative 37. I'm going to subtract 7, subtract 7. Final answer, here it is. X equals negative 7 plus or minus the square root of 37i. I'll rewrite that one more time just so it's really clear in the answer key. I'll just redo that. Let's see. I can fit it in somewhere. Let's see. We'll just take this all the way down here. All right, so one more time. We had x plus 7 squared equals negative 37. We took a square root. X plus 7 equals plus or minus the square root of negative 37. We subtracted 7, we got x equals negative 7 plus or minus the square root of 37i. And that I is outside the square root. The square root ends here. And then there's the I after it. That I represents the square root of negative 1, which jumped down of our answer. So that is the final answer there. All right, one more quadratic formula. I'll add 5. 4n squared plus 5 equals 0. A equals 4, B equals 0, C equals 5. We get negative B, so negative 0 plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. This simplifies here to be plus or minus the square root of 16 times 5, 80, all divided by 8. And I'm going to leave the answer like that. Plus or minus square root of 80 over 8. That was 19. They got an I in their answer. Oh, minus 4AC. So this should have been a negative 4, negative 80, which means we can't leave the answer like this. We got to convert that to plus or minus the square root of 80 I over 8. And I'm fine with you leaving it like this. So don't leave it like this. Leave it like what I've written in pink there. Okie doke. Sketch a graph of this function. I'm going to take the right-hand side there and convert it to vertex form. To do that, I need to divide everything by negative 2. Yeah, y over negative 2 is greater than x squared plus 6x plus 10.5. Create the structure here. This value here is always half of b. We subtract away that number squared. And we send the negative 2 back. which comes up with this equation here. Y is greater than -2 x plus 3 squared minus 3. I'm noticing a slight mistake in my work. When I divided by a negative, my inequality should have flipped until I multiplied by a negative, and then it should have flipped back. So ultimately, I've got the right answer. But in these intermediate steps, it should have been facing this way. But then it flips back. So if you're going to forget to do it twice, and then you'll get the right answer. All right, so I've got to put a point at 3, -3. From that point, I'm going to go down 2 to both sides. All right, so that's my 1, 4, 9 pattern became -2, -8, -18. So I went down 2. Now I want to go down 8 from the vertex. Brings me to this point here. I want to connect that up with a dotted line because it doesn't have the or equal to part. Okay. Now I want to get my shader, and I want to shade above this parabola because it's a greater than symbol. So we want to dot and shade above. That's what that the greater than symbol means. And this is above. It's this part here. Okay. Last problem. It's this system problem here. In order to solve it, I have to do something very similar to what I did to number 22. I believe this is not the one that I solved in class. Let's get started, see what happens. All right, so I need to get x by itself. So let me add 3y and add 1 to both sides. Look at x equals 3y plus 1. Now I can substitute that in for that x value there, which gives us, I'm going to have to take this much further down on the page, -4y squared plus 3 times the quantity 3y plus 1 minus 13y plus 21 equals 0. Minus 13y plus 21 equals 0. First step here is going to be to distribute that 3. Now I've got -4x squared plus 9y plus 3 minus 13y plus 21 equals 0. Now I want to get together all my like terms. -4x squared minus 4y plus 24 equals 0. Why don't I divide away a -4 to make my life a little bit easier going forward? And I'll get x squared plus, oh wait, that wasn't an x, that was a y. A y that slowly became an x. Okay, these look more like y's. Y squared plus y minus 6 equals 0. This can be simplified using simple factoring. Just create this structure here. Two numbers that multiply to be -6, but add to be +1. That's going to be a +3 and a -2. And then we get y equals -3 and y equals 2 after using the zero product property. Let's plug those into my expression up here. X equals 3y plus 1. Just keep going down. Y equals, I think it's x equals 3y plus 1. X equals 3y plus 1. X equals 3y plus 1. And we get x equals 3 times negative 3 plus 1. X equals 3 times 2 plus 1. Keep going down. X equals negative 9 plus 1. X equals 6 plus 1. X equals negative 8. X equals 7. To give us our final answer, negative 8 comma negative 3 and 7 comma 2. All right. That is all the problems. I will post this on the website. Thanks to the 2 students that stopped by and asked questions. Hopefully, for those of you watching this later, you get a lot out of this. I'm sorry you weren't able to ask questions, but that's the way it goes. And I will see you on Monday.